Hello, hello, hello. We are already at Unit 2, Lesson 6, adding and subtracting like fractions. So with like fractions, we have like denominators. So we can add fractions that have like denominators with numbers. We can also add fractions that have like denominators with variables. So we're going to look at both of those things, which means we're going to take what we know from fractions from 5th grade and step it up to 7th grade with negatives and variables. First of all, the definition for like fractions are fractions that have the same denominator. When we add fractions with like denominators, we add the numerators and then write that sum over the denominator. The denominator is really just giving us a size. What's the size of something? The numerator is telling us how many of that thing we have. So in the first problem down here, if we have 7/10, we have 7 pieces that are each worth a tenth. And 6/10, we have 6 pieces that are each worth a tenth. So in order to add them together, we would add the 7 and the 6 and say we have 13 pieces that are each worth a tenth. Now, if this were pizza and we wanted to combine them all into one box, we would say we have 1 whole pizza and 3/10 of a pizza extra. So 10 goes into 13 one whole time with 3 left over. All right, so now let's look at another one. This one has a negative in it. If we have 5/8, so we have 5 things that are each worth an eighth, plus negative 7/8, we have negative 7 of something worth an eighth, we have to add 5 plus negative 7. So those two numbers have different signs. We're going to find their difference, which is 2 and more negatives. So it's negative 2/8, and then lowest terms, we would go with negative 1/4. So if you ever have any of these and you've got multiple steps, it might help to put the final answer in a little circle or oval there. Negative 4/7 plus 6/7. I have 4 negatives that are each worth a seventh, and I have 6 of something that's worth a seventh. So I'm going to add together that negative 4 plus 6. The signs are different, so I have 2 more positives than negatives, and I would get 2/7. And that would be my final answer. Now, the next one has variables. 3x sevenths plus 2x sevenths. So whatever 3x and 2x are worth, I can combine them by adding them together and say that whatever these things are that we have, they are a size seventh. Another way to look at this is to say we have 3x tiles plus 2x tiles. So altogether we have 5x tiles, and they're worth a seventh each, 5x sevenths. All right. And then what if they're mixed numbers? Now, when we were doing multiplying and dividing, we were saying, no, you can't have a mixed number. You've got to go to an improper fraction. Well, adding and subtracting always get their own set of rules. So what we're going to try here is adding the whole number together, or the integer together, separate from the fraction part. So we're going to do 2 separate problems. We're going to add, in this case, the whole numbers, 2 plus 3, and the fraction part, 3/8 plus 7/8. So 2 plus 3 gives us a whole number of 5. 3/8 plus 7/8 gives us 10/8. We got a little work to do on that 10/8 because 10/8 is worth 1 and 2/8, but in lowest terms, it's worth 1 1/4. And we've still got to put that together with our other 5. So 1 1/4 plus the 5 wholes would make 6 1/4 for a final answer. So that is another strategy that works really efficiently for adding and subtracting mixed numbers. So let's look at the next one. And what's really tricky for this next one is that it's a negative 2 3/7 and a negative 4 5/7. And everything in that mixed number is negative. So it's a negative 2 and a negative 4. Those are the integers. And then I've also got a negative 3/7 and a negative 5/7. Notice that the 2 and 3/7 both have negative signs. The 4 and 5/7 both have negative signs. Because if you said something like, I owe you $2.50, I owe you $2, and I also owe you 50 cents. They're both negative. So it's the same idea here. The integer, the whole number part, that's negative. Clearly, those are both negative, but the fraction parts are also both negative. So negative 2 and negative 4, same signs, gives us negative 6. Negative 3/7 and negative 5/7. If I combine those, negative 8/7, right? Because I added together my negative 3 and my negative 5. Negative 8/7 is worth negative 1 because 7 goes into 8 one whole time. Negative 1 and 1/7. And then I would have to combine my integer, the wholes, with the fraction part and get negative 7 and 1/7 as my combined answer. So you're going to have a whole number or an integer part to your answer, and you're going to combine that with the fractional part of your answer to get your final answer. And what we don't want in 7th grade, we don't want you switching everything to improper fractions because that is not our goal. We want to elevate what we're doing to be efficient. All right, subtracting fractions. Same concept. To subtract fractions with like denominators, we're going to subtract the numerators and keep it over that same denominator because we have 3 things that are each worth a tenth. Take away 9 things that are each worth a tenth. We are going to change that subtraction to addition. So it's going to be 3 plus a negative 9. We're going to add the opposite, which is negative 6. So we're going to have negative 6/10. And lowest terms, that would be negative 3/5. So I still rewrote the problem at the top, the 3 minus 9. I rewrote it as 3 plus negative 9. Next one, 5 minus a negative 10. Notice it's minus a negative. 5, we're going to add the opposite, which would be a positive 10. And we would have 15/15. And if you have all 15 pieces and they're each worth a 15th, that is the same as 1 whole. Great. Negative 3/9 minus 4/9. So that is a negative 3. We're going to change it from subtraction to addition. Instead of a 4, we're going to add the opposite, which is negative 4. So now the signs are the same. Negative 3 and negative 4 makes negative 7/9. And last but not least, if I have 7 x tiles, so let's say 1, 2, I don't know if I'm going to fit these in here, 3, 4, 5, 6, 7. So if I have 7 x tiles and you take away 3 x tiles, 1, 2, 3, you still have 4 x tiles remaining. So this one is 4x eighths. I still have 4 x tiles. If I have 7 x's and I take away 3 x's, I still have 4 x's, eighths. And then lowest terms, the 4 and the 8, I can simplify that like I simplified earlier when we were multiplying. 4 divided by 4 is 1. 8 divided by 4 is 2. And I would have 1x over 2 or just x over 2. You can also think of 4/8 as a fraction, would be 1/2 in lowest terms. All right, now the last part that's here is how do we regroup if we need to subtract fractions and we have a smaller one take away a bigger one? How do we regroup? So the part that's up here is kind of messy to just look at if you're not actively doing it. So what I'm going to do down below, I'm going to actively do a couple of these problems, and then we're going to look to see if it matches the pattern that's up above. 4 and 1/7 take away 2 and 5/7. Do you all agree that if I tried to do 1/7 take away 5/7, I don't have enough 7ths to do 1/7 take away 5/7? I'd have to go into the negatives. Well, in order to avoid that, we're going to do something called regrouping. We're going to take away one of the whole numbers. So instead of having 4 wholes, we're going to go down to 3 wholes. Because a whole is worth 2 over 2, 3 over 3, 4 over 4, 5 over 5, or in this case, 7 over 7. So I'm going to take that 1 whole, and in my head, I'm going to think about that 1 whole being renamed 7/7, and I'm going to add it together with that 1/7, which makes it 8/7. So what happened to the whole number? The whole number went from a 4 down to a 3. So my whole number decreased by 1, right? The 4 went down to a 3. The next thing that happened was what happens to the numerator? So my numerator was a 1 and it became an 8. And if you notice, the 2 parts of the fraction here, 1 and 7, add up to 8. So in order to get my new numerator, I actually add the numerator to the denominator. And that gives me a new numerator. And we're going to do a couple more of these, okay? And last, what happened to the denominator? It was sevenths. It stayed sevenths. The denominator stays the same. All right. So the reason we do this, I can't do 1/7 take away 5/7 without it going into the negative. But now I can do 3 and 8/7 take away 2 and 5/7 and do 3 take away 2 is 1. 8/7 take away 5/7 is 3/7 and have an answer that's done and did not go into the negatives, which is really helpful. So if you look up here, I had a 5 for my whole number. Look at the final answer. The whole number is a 4. It went down by 1. I had 6/11. If I add 6 and 11 together, you get the new numerator 17, and the denominator stayed the same. If you look here, the 9 went down to an 8. That's our whole number. The 2/3, if I add 2 and 3 together, I get 5, my new numerator, and the denominator stays the same. 12 and 1/15. The 12 whole number went down to an 11. If I add the 1 and the 15 together, I get 16 as my new numerator, and the denominator stays the same. For this one, the whole number 1 went down to a 0. And if I add the 4 and the 5 together, my new numerator is a 9. So I just get 0 and 9/5 or 9/5. So if I look at this one and I go, Mrs. Fraser, 3/8 take away 5/8. If you're going to try to do 3/8 take away 5/8, you're going to have to go into the negatives. And I say, no, I'm going to regroup. So the 9 is going to go down to an 8. The 3/8, I'm going to add 3 and 8 together and get 11, and the denominator is going to stay 8s. And then I can take away my 5 and 5/8. So 8 take away 8 take away 5 is 3. 11/8 take away 5/8 is 6/8. And I notice that 6/8 is not in lowest terms, and it's going to be 3, divide by 2, and 3/4. Last one. You can always pause me and see if you can try this one on your own before I do it. So feel free to hit pause. 5 and 1/11. The 5 is going to drop down to a 4. The 1/11, if I add the 1 and the 11 together, I get 12, and the denominator stays 11. And now I can take away my 3 and 6/11. Before, 1/11 take away 6/11 was going to get into the negatives, but not now. 4 take away 3 is 1. 12/11 take away 6/11 is 6/11, and I'm done. So the regrouping of the first mixed number, the regrouping of it, which I guess you guys can probably notice, the numbers stayed very small. I didn't have to do a lot of changing denominators. I didn't have to deal with big numbers. I didn't have to make any improper fractions. If you can master those 3 steps for regrouping a mixed number, it actually takes a whole lot less work than doing improper fractions. So decrease the whole number by 1, add the numerator and denominator together, and that gives you your new numerator, and the denominator stays the same for regrouping. And we only use this when we're subtracting mixed numbers if we were going to have to go into the negatives otherwise. So sometimes you won't need this at all. If you do have questions, please make sure that you bring them to class, and we can do several of these examples live in class. Bye.